or it will become straight. So there's a sequence you take it. So now the B, what will happen is having a velocity. Very next moment the string will become taut. There's a sequence what you can show it now. After this, what will happen? First problem, and I'm just giving all set of diagrams, so you should really manage the things. The string will become taut. Suddenly string will be jerked and impulse will be set up. And this impulse, what it will do to the particle A and B is what we have to check it now. What will happen after this? Just after the jerk, is asking just after the jerk. So we'll resolve, this will be angle theta. So we'll resolve this velocity into two parts. One u perpendicular, the other will be u parallel. I'm resolving the velocity of the particle B into two components. U perpendicular, other will be u parallel. Now how the impulse J will act along the string. So the u perpendicular should remain as it is. I'll call that as VB perpendicular. This will be VB parallel. So V perpendicular, will write it simple. It will be because the impulse will act in what direction this will move? This will move along the string, that one. So this will have velocity V parallel. This is what the sequence happens. Component of velocity perpendicular to string, what happen will not be disturbed. Only the component of velocity along the string, what will happen? That will change here. Can we apply? So masses are m each. This is now taut. String is jerk. This is just string is what happened about to jerk. No, string is jerked here. Then impulse is set up. Okay, let's what is u perpendicular? Can we calculate first what is theta? I think from the triangle. This will be 2L and
30
this is L.
degrees.
Okay, theta 30 degrees. So we know theta 30 degrees. So this should be theta and this should be theta. So what is u perpendicular? U sine theta. U parallel will be u cos theta. U by 2, u root 3 by 2. So what should happen to V perpendicular? V perpendicular must be equal to U perpendicular. Component will not change. How to calculate V parallel? Applying conservation of linear momentum along the string. Along the string. So they should be MV parallel should be equal to initial momentum mu parallel, final momentum MV parallel plus MV parallel. So what is V parallel? U parallel by 2. U parallel is U root 3 by 2 by 2. So U root 3 by 4. And this should be equal to U by 2. So what is the velocity of particle B? V parallel square plus V perpendicular square. What is the velocity of particle A? It should be equal to only V parallel. Now, I'll ask you for some very good questions. Like this is the initial situation and this is the final. Let's calculate energy. Initial energy is how much? Mu square. Final energy is how much? M VA square by 2 MVB square by 2. Can you say anything about the energy here? You must focus on this. The books, you see, the question I picked up from book. Okay, they didn't bother, but we must do learn because when we go for mixed concept, this particular decrease in kinetic energy, where do it will go? Converted as heat. So therefore, this must be an inelastic string. And what will happen to it? It will convert when it absorbs heat. Temperature of that will increase. Thermal expansion occurs slightly. The length of the string will increase. I'll bring this into thermal expansion. Find the increment in the length of the string. That's all. These are the most troublesome questions for you. So from the impulse, I'm taking you to thermal expansion ideas. Just after jerk, so here often when it jerk, no, so that heat will happen, whatever the decrease in kinetic energy will be converted into heat and that will be absorbed by the string. Or we can call that as strain energy. In books, they call that as strain energy. Converted into increase in strain energy of the string. I don't get sound energy, am I right? So it's a very rare we'll get a sound energy. So maximum you should go for will be absorbed by the string in the form of heat. So here loss in kinetic energy, delta K. Ki minus Kf will be absorbed by the string. You have to be very careful about these conceptual things. Will be absorbed or heat generated will be absorbed by the string. So now different types of questions will be available. You have to be very careful.
Sir,
No.
how did you say that both A and B will have same velocity, sir?
They're connected by common string. You see that one, inextensible, no string. So velocity of B along the string must be equal to velocity of A. Then the string is inextensible.
Okay, sir.
Inelastic, inextensible string. Constraint equation, velocity of the ends along the string must be equal. Y, I'll write corner here. Velocity of ends along the string must be equal. Reason for that? Inextensible, no? As the string is